Okay, so the final exam is Tuesday, December 6th in our classroom. And my 9:30 class will take the test from 10 a.m. to 12 p.m. And my 2 p.m. class will take the test from 3 p.m. to 5 p.m. on December 6th. So this is the review for the final exam. And the final exam is pretty much covers basic concepts. There aren't any problems that are, I would consider, very challenging, maybe one or two, but so I'm just going to cover the basics today. And if you want to study for if you want to review, practice problems, I'm going to be opening up the online exams. Now, we took them on paper, but I have them saved online. So these would be similar to quizzes that you took. And you can practice, or you can go in and review your old quizzes and retake them, whatever you want to do. I think I set the deadline, the final deadline for the quizzes to be December 5th in the homework, but I'm going to change that to the 6th so that if you want to study on the morning of the 6th, you can. So anyway, you can go in and review practice problems on the quizzes or do the tests, which I'm going to open up after everyone has taken their tests. And so let's dive in. There are 40 questions and they are multiple choice, all of them. That's just so I can grade it quickly and get my grades posted. They cover the 4 units pretty evenly, so it's comprehensive, meaning it covers all the content of the course. But I have left out some things, like I don't have any problems where you have to solve oblique triangles. Those were fairly involved, and these are just quick multiple choice questions. So you would have to be you would have to solve like a right triangle, but not an oblique triangle. So you should know how to convert angles from degrees to radians. So degrees to radians and vice versa. Radians to degrees. So for example, if you're given an angle that in radians, so suppose you want to convert pi over 3 to degrees. Okay. There we go, that's better. Okay. So know how to convert angles from degrees to radians and radians to degrees. Remember, we used a conversion factor. So if you have something like pi over 3 and you multiply, there are 2 of them. So you want to make sure you use the right one. So the conversion factors are pi is equivalent to 180 degrees. And so pi is in the numerator, or you can have the degrees in the numerator and you're dividing by pi. These are 1 because they're the same thing. So when you're multiplying your angle by 1, you're not changing your angle. Since the pi is in the numerator and we want to convert to degrees, we want to get rid of the pi. So we want to divide out by the pi. And so we're going to use the conversion factor 180 over pi. And then the pi's will cancel and you get something like 180 over 3, which is 60 degrees. Okay. Now you should also be able to go it the other way. So let's say you're given an angle like 270 degrees and you want to convert it to radians. So if you're doing that, you're going to multiply by, this time you're getting rid of the degrees, so you want the degrees to be in the denominator. You're dividing out by the degrees and multiplying by your pi. You're introducing that pi. Okay. So if you're going to reduce 270, well, you can cancel a factor of 10 out, and then each one has a factor of 9. So this is going to be 3 pi over 4. So you divide 270 by 90 to get 3, and you divide 180 by 90 to get 2. Sorry, I put a 4. I meant 2. Okay. So that's how you do those problems. Now, you may run into a situation where you can't reduce, simplify the factors. So how would you do that? So let's say you have something like 266 degrees that you want to convert, okay? Well, the degrees are in the numerator, so you're going to multiply by pi over 180, and you can reduce this fraction, but sometimes it'll say use pi equal to 3.14 or something to that. Or I think it's 3.1416 is what they'll say, if I remember correctly. Let me check pi real quick. Calculator. So yeah, 3.1416 is what I think they ask you to do. So in that situation, when they say use pi equal 3.1416, then you're going to just do your calculation on the calculator. So you're going to have the degrees will cancel here, and you're going to have 266 times 3.1416 divided by 180. So going to the calculator, you're going to say, let's see, 266, and this is important, okay? You've got pi over here, but don't use that pi, okay? You're going to use pi equal 3.1. So you're going to be multiplying by 3.1416 because you want your answer to match the answer that's in the multiple choice. So it's 4.64, but be careful. You want to do it in radians. Actually, I don't think it matters in this case. Let me see. You're going to get the same answer either way. Sometimes it matters if you do it in radians, but we're just doing calculations. So we're not actually doing like trig functions. So I'm just going to double check that to make sure I'm right. Yeah. So we have 4.64 if we round it to the nearest 100.
How would you just really change?
I'm sorry?
I was wondering why you already had 266 over 180.
Right here.
Yeah.
Okay, because the original problem is 266. We're converting that to radians. But instead of just leaving the pi there, the instructions in the problem say use pi equal 3.1416. So when you do the calculation, you want to use the pi that they give you instead of the symbol or instead of the calculator pi. so that your answer will match their answer. Does that answer your question?
Yeah.
Okay. Let's- Oops. Okay, another thing that you want to know how to do is work with angular speed and arc length. So you should know this formula because I'm not going to give it to you on. This is just a simple formula. They're actually two formulas. They're related though, so they all come from the same formula. But know this formula. And it is S equals R theta. So S is the arc length. And R is the radius. And this theta is called the central angle. And let me show you what I mean by that, okay? Because you've got a circle and you've got your angle in standard position. So let me get a different color here. Remember, every angle can be represented in standard position by lining the vertex up with the origin. And then, so this is your theta, and then the radius of the circle, sorry, it doesn't look like a circle, but it is. The radius is the distance from the origin to the edge of the circle. That's your radius. And so the arc length is the distance from the point on the x-axis with the point that intersects where the terminal angle intersects the circle, okay? So the two intersection points of the angle with the circle, the distance along the arc is your S. And the relationship between S, R, and theta is that S equals R theta. Now, this is a very important point here. This has to be in radians, okay? Theta must be in radians. Because this relationship is directly connected to the definition of radians, and it doesn't work if your angle is in degrees, okay? So this is a very important point. If your angle is in degrees, you'll get the wrong answer, okay? It must be in radians, okay? Make sure you remember that. Now, from this formula, S equals R theta, you can divide everything, both sides by T, which is time, okay? So T, and that introduces a new idea of theta divided by T. So that is angular speed. And then the S over T, because S represents a distance, you're taking the arc length, which is a distance, is divided by time. Distance divided by time is linear speed, okay? So like if you're driving in a car, even if you're driving on a curve, like this arc length is a curve, it's still a linear speed that you're talking about because you're following the path of a line, so linear speed. Whereas angular speed has to do with how fast you're rotating. That's a different kind of speed. And in this class, I don't like the use of the letter V, but in this class, we use V for speed. V really means velocity, and velocity and speed are not exactly the same thing. They're related, but if you're a physics student, you know they're different. So just kind of, we're not doing physics. I mean, we are kind of, but just kind of call it a V, even though it stands for speed. So the linear speed, we say V, and the angular speed, we say omega. So that produces a new equation. V equals R omega. And this relates linear speed with angular speed. So you've got a couple of formulas here. You should be familiar with S over T. That's just distance divided by time. That's your speed. Then you've got theta divided by time. That's your angular speed. And then you have two equations, S equals R theta and V equals R W. Omega, I mean, R omega. So let's look at an example so we can see what we're talking about here. I kind of have sketchy notes here. Maybe we should look up an example. Let's do that. So this comes from unit 1. So I'm going to go into the review for unit 1. Just to look up an example here. I think it's at the end of the assignment. Actually, let's see, where is it? Here it is, 5.1. Express angular speed in radians per second. And got a better idea. Why don't we do this? Let's go in here. There we go. Okay. All right. So here we have a good example. Find the positive radian measure of the angle that the second hand of a clock moves through in the given line, given time in 18 seconds. Okay, so we have a clock. You should always draw a picture when you do these to kind of help yourself. If you have, so we have 18 seconds. So let's say it's coming, it starts at the top and it's coming down. $18 seconds. Actually, it's going to go past right about here. And if you look at the relationship between 18 seconds, think of it 18 over 60 is going to be 3 over 10. So 3/10. And if you multiply that by 360 to calculate the number of degrees, you're going to actually, if you say, let's do radians. You're going to have 6 pi over 10. And if you simplify that, that is going to be 3 pi over 5. Okay, so let's look at this. we have 18 seconds out of 60 seconds. And I put 360 there, but it's better to use 2 pi because remember your answer needs to be in radians when you're doing this relationship thing. And you take 3/10 times 2 pi. This is 1 revolution. You've gone 18 seconds out of 60. That's 3/10 of the complete circle. So that's 3/10 of 2 pi. And so your in radians, your angle is going to be 3 pi over 5. Now, the way I've driven it, I drew it according to a clock, but I don't think they want the negative angle. They're just assuming, they just want the absolute value of the angle. So let me look at their problem again. Let's see. It says find the positive radian measure because a clock goes in the negative direction, right? But they wanted the positive. And so you can see it's 3 pi over 5. So this is the probably the most difficult type of situation that you're going to run into as far as these problems. They're not any really hard problems, pretty basic. Let me show you another example. Let's suppose you have like something like a pendulum and that's swinging. And let's suppose you want to find the arc length when it passes through an angle of 45 degrees. That doesn't look like 45 degrees, but just humor me. So you might have to find the arc length, but what you have to know when you do something like this is you have to know the length of your pendulum. So S equals R theta. If you're looking for arc length, it's okay to find the theta. Let's say it's 45 degrees, but you also have to know the R. So let's say it's 10 inches, okay? If you know the angle and you know the length of your pendulum or whatever it is, could be a clock, whatever it is that's swinging through the angle, whenever you have a fixed length, it's going to create a movement that is like in an arc. And so you can measure this distance that it's moving. But be careful. Notice how this problem is set up. It's in degrees. So before you can solve the problem, you want to convert theta to radians. So theta equals pi over 4. And then you just take your R, which is 10 inches, and S equals 10 inches times your radian measure of your angle, which is pi over 4. And so we get 5 pi over 2 inches. Now they may want it in this format, or they may want you to actually calculate the inches. And so we can go to our calculator. And you would just take whatever they a lot of times they'll give you 3.31416 for pi. And then you're going to multiply that by 5 and divide by 2. So you get 0.79, if you know. That doesn't seem right. What did I do wrong? I put the wrong value for pi in. Hold on. There, 7.854. Or let's say 7.85 if you round it to inches. Okay. So that's kind of the type of problems that you would want to be able to do. If you feel like, you can go and review your quizzes or your tests. That's what I would do, is I would go over my tests and just practice that way. You should also be able to use a calculator to calculate trig functions at different angles. So, do you have any questions on this before I move on? I'll wait till you're done writing. Okay. Okay, just be careful with the calculator. You want to remember to put it in degrees or radians. So select the right mode, which is degrees or radians. Okay, be careful about that. Because whenever you have a problem that asks you to use your calculator, you think, oh, wow, great, this is easy. But there are some things you got to pay attention to, so don't forget that. Also, be careful because let's go look at the calculator here. Notice that we have cosine inverse, sine inverse, and tangent or inverse. These are not reciprocals. These are inverse functions. It's something entirely different than taking the reciprocal. We use -1, like so x to the -1 is the reciprocal of x, but cosine, sine, tangent to the -1 is not the reciprocal. So just be careful. This is your reciprocal down here, 1 over x. And on your calculator, it might say x to the -1. Okay, that is the reciprocal of x. That's the key you want. Don't get sucked into seeing that -1 and think, oh, reciprocal. Yes, it does mean reciprocal, but it also means inverse function. So that's what it is in this case right here. So be careful of that. Also notice your calculator only has the main 3 functions. So if you want to calculate secant or cosecant or cotangent, you're going to have to use the reciprocal function down here. So after you do the calculation, then you're going to hit this button here. So let me do some examples. Say you want to evaluate secant of 32 degrees. Okay. So the first step is to recognize that secant is the reciprocal of cosine. Okay. Secant is the reciprocal of cosine. So secant of 32 degrees is going to be 1 over cosine of 32 degrees. So this is the function you're going to use on your calculator. So I'm going to my calculator here. I know I'm going to use my cosine function, but first notice that my calculator is in radians and the problem is in degrees. So I got to switch over to the degree mode. That's your first step. Don't forget to do that. Then you're going to do cosine of 30. Let me clear out my calculator. Cosine of 32 degrees. You're going to close the parentheses. Okay. So this is not the answer yet. Now you're going to hit that reciprocal button because you're actually finding secant of 32 degrees. There you have it. Now, so the answer is 1.1792. Okay. 1.1792. Now, I think on the, you won't have to worry about, you know, what place value to write it at because it's multiple choice. So the answer will be there. But I guarantee you, they're probably going to have the other answer there. I just know that that's how my lab math does it. They're trying to catch you in making those common mistakes. So like if you forget to take the reciprocal, you're going to get 0.848, and that will be one of the answers. So just be really cautious. I know using your calculator is an easy thing to do, but these are tricky, so be cautious. On the calculator, so you're going to take, first of all, you check the mode, it's in degrees. Then you take cosine of 32. Okay, once you've gotten that, then you take the reciprocal of that. because you really want secant of 32. And there's your answer.
It's just do 1 divided by.
Yeah, don't do cosine inverse. That's an entirely different thing. That is not secant. Cosine inverse and secant are not the same thing.
All the questions on the thing, on the exam was.
Mhm. That was just to make it easy on me, because at the end of the semester, I have all these grading to do. So. All right, let's do another one. So the next one we're going to evaluate is cotangent of negative 2 pi over 3. Okay, so what you'll notice is, first off, you see the pi there, so you know this is in radians. There's no degree symbol. So we're going to put our calculator in radians mode, and then we're also going to calculate 1 over tangent of negative 2 pi over 3. Okay, so going to the calculator. Notice it's in degrees. I got to switch it over to radians because my angle is in radians. Then I take tangent of 2 times pi divided by 3, and I got to change the sign. And I get 1.7321, but I'm going to take the reciprocal of that because I really want cotangent, which is the reciprocal of tangent. So it's 0.5774 if you round it. Now, sometimes they're going to ask you to find the exact value or use a reference angle to find the exact value. And in that case, you're going to use your unit circle to calculate it. You're not going to use your calculator. It'll even say, don't use your calculator. Now, I know a lot of people are going to use their calculator anyway, and that's fine. You're allowed to use your calculator, but what they mean is they want you to put it in the, write it as a fraction with a radical and all that stuff. Okay, that's what they mean. So, an example would be use reference angles. Calculate. Or trig, or evaluate trig functions. Let me think of an example. Tangent. Let's see. Minus 60 degrees. Okay. Now, there are a number of ways you can do this problem. You can just use your calculator, and then you can kind of, figure it out. So maybe some of your calculators write it as a radical. Do you have calculators that do that? No? Okay. So let me just show you how you use the unit circle. They say use a reference angle. You can just go to the unit circle and do it, or you can, what they mean by reference angle is, so reference angles are always acute. Let's talk about that for a minute. And they're positive too. They're positive and acute. And basically, what they mean is they're disregarding how the angle is situated, which quadrant it is in. Since a reference angle is always positive and acute, it's always in the first quadrant. But like, see this angle here, negative 60 degrees, okay? This is negative 60 degrees. And the size of the angle, even though it's in the fourth quadrant, what angle has the same size in the first quadrant? Well, that's 60 degrees, right? It would be up here. is the reference angle, okay? So they have the same rotation, it's just in the same amount, so you're rotating it. But this one is a negative angle and this one's a positive. So reference angles are always acute, they're always in the first quadrant, they're always positive. Now, we don't always draw them in the first quadrant. So for example, if you have an angle that's over here, so this would be your theta, and I always use alpha to show my reference angle. So here, if we're looking at this angle, let's say 3 pi over 4, okay? This is an obtuse angle. So to reference this angle, we look at the angle that is formed by creating the triangle there. And if you're just talking about inside this triangle, this right triangle, the angles are all acute, right? So we know this is an acute angle. And the measurement is supplementary to this angle. So this is 135 or 3 pi over 4. This is going to be pi over 4 or 45 degrees. That's the reference angle. So it's acute. And depending on which quadrant you're in, it may be supplementary with your main angle, or it might be, if it's in the third quadrant, you're going to take your angle and subtract 180 to get your reference angle. But the point is, it's the reference angle is formed by making the right triangle. So it's an acute, and we always take the positive angle, okay? So back to this problem here. The reference angle is 60 degrees. So when you go to the unit circle, if you look at the first quadrant, at 60 degrees, this point here is x equals 1/2, y equals square root of 3 over 2. And so when you're calculating tangent, the absolute value is tangent of 60 degrees, okay? So you get the value, which is square root of 3 over 2 divided by 1/2. So you calculate the value first, and that is going to be square root of 3, okay? However, we're taking tangent of negative 60 degrees, and that is going to be in the fourth quadrant, and tangent is negative in the fourth quadrant. So we'll write this note here. Note, tangent is negative in the fourth quadrant. So tangent of negative 60 is negative square root of 3. So when they say use the reference angle to calculate it, you're disregarding the sign. And then after the fact, you use all students take calculus to know, oh, tangent is negative in the fourth quadrant, negative 60 degrees is in the fourth quadrant. So I know the sign of this thing is going to be negative. So that's what they mean by using the reference angle. But you can just use the unit circle because you all have the unit circle available to you. So you don't even have to really use the reference angle and do it separately. It's just what your preference is. Just be able to calculate trig functions using the unit circle. So that they don't want the decimal, they want it in this format. Let me do another example. That's kind of a review of reference angles there. Let's see. Why did I do that? Oh, here we go. Must be 5.2. I think it is. There it is. Use reference angles to evaluate trig functions or trig expressions. Let's see, let's do another example. Here we go. This is a good example. Okay, this time it's in degrees. So we're looking at tangent of 765. I don't want you to use your calculator, but actually in this example, you can see the answer there is 1. And so you could have used your calculator there because your calculator is going to show you it's 1. But let me just do this using the unit circle. Pretend I don't have a calculator. Okay, so tangent of 765. First off, notice that this angle is way out of range. It's not between 0 and 2 pi or 0 and 360. So we are going to bring that down and find a coterminal angle. So I'm going to subtract 360 and I get 405, right? And that's still too big. So I'm going to subtract 360 again to bring it down into the right range. And that is going to be, let's see, 45 degrees. Okay, now I go to the unit circle. 45 degrees is right here. And you're going to have your unit circle and you're going to see the point is square root of 2 over 2, square root of 2 over 2. And tangent of theta is going to be y over x, right? Know these relationships. Cosine on the unit circle. This is important on the unit circle. Not on every circle, but on the unit circle. Tangent theta is y over x. Of course, sine of theta is just plain old y, and cosine of theta is plain old x. So since we're at 45 degrees, this is the reference angle, right? It's in the first quadrant, it's acute, it's positive. This is the reference angle. So I'm going to use this angle to calculate tangent of 765. And tangent of 765 is the same as tangent 45, which is going to be square root of 2 over 2. That's your y value. And then over square root of 2 over square root of 2, which is 1. Now I know you can calculate this on the calculator and you can use whatever method you want. If it says use reference angle, I mean, you don't have to in every circumstance. Now, sometimes you will if it's a radical or a fraction or something like that. But. All right. Any questions on that? Let's do another one. Just practice. Oh, let's see. All right. Here we have sine negative 315 degrees. Again, this is, you want a coterminal angle. So I'm going to, this is 315 degrees. You're going to add 360 to that. So it's going to be 45 degrees. When you add 360, this is the reference angle. It's positive, it's acute. And so you're going to take sine of 45 degrees. Now, when you do your calculator, it may give you a decimal value, but they want square root of 2 over 2. You're going to use the unit circle. So going to the unit circle, you see here at 45 degrees, the sine is the y value. So it's square root of 2 over 2. If you're looking at something like, let's say, cosine of 2 pi over 3, okay, 2 pi over 3 is not in the first quadrant. it is between 0 and 2 pi. So it's actually in the second quadrant. So you can use your unit circle to see where it's located. And in order to get to 180 degrees, I'm going to form a triangle here, and this is pi over 3. This is the reference angle. So cosine of 2 pi over 3 is negative, okay, since cosine is negative in the first quadrant, or second quadrant, we're in the second quadrant. So we know it's negative, and the actual value, we can use our reference angle, cosine of pi over 3. This point here is negative 1/2 square root of 3 over 2. So you can see that if you're just using the positive cosine pi over 3, you're not going to get the sign if you use the reference angle. So you got to make sure that you know it's negative. And that's from all students take calculus. All of the trig functions are positive in the first quadrant. Only sine and its reciprocal are positive in the second quadrant. And then tangent is positive with its reciprocal in the third. And then cosine is positive here. So we're in the second quadrant, so cosine is negative, and so we get negative 1/2. Okay. All right, so moving on, we've kind of covered that enough. Make sure, now moving into unit 2, make sure you know how to calculate the amplitude, the period, and the phase shift. So let's look at some examples like that. Sorry, I'm having trouble here. Well, let's see. Here we are. Okay, so moving on, we're going to go to section 5.5 now. And I'm not going to ask you to graph. I just want to know, what is the amplitude? What is the period? What is the phase shift? So let's look at some examples. So here we have y equals 3/8 sine x. The amplitude is always the constant in front of your trig function, and the amplitude is always positive. So even if your constant happens to be a negative number, your amplitude is always positive. So looking at this example, it's just 3/8. Okay. Let me see if I can find it. Here, there is no constant in front of the sign. Y equals sine 6x. So the amplitude is 1. If there's no constant written in front, it's understood to be 1. All right, I wanted to do one where it was negative. Let me just do it on paper. So like I said, if it's something like y equals -5 cosine, let's say 2x plus pi. Okay, here's our example. The amplitude is the absolute value of the leading coefficient or constant there in front. So the amplitude in this case is the absolute value of -5, which is 5. Now, if you want to calculate the period is you take your old period divided by B. Now, what is B? Okay. This constant is A, this constant is B, and this constant is C. Okay. So, the old period, the period for sine and cosine sine and cosine is 2 pi, and that would be the same for secant and cosecant. And then tangent has a period pi. Okay. So the old period, if you're talking about sine or cosine, it's 2 pi, and then you divide it by b. That's the constant in front of the x, is your b. So in this example, we have 2 pi over 2, which is pi. So this is the new period. Okay. Okay, this is the amplitude. And finally, how do you calculate the phase shift? Okay. So the phase shift is you're going to take C over B. So in this case, it's going to be pi over 2. But because pi is positive, so if this is positive, you're going to have you shift to the right. I'm sorry, to the left. And if negative, you shift to the right. Okay, so in this case, we are going to, the phase shift is pi over 2 units to the left. And actually, I think if you say what is the phase shift, it would be negative pi over 2. I didn't include the negative sign here. So the phase shift is always the opposite sign of this. But when I'm calculating it, I just look to see if it's positive, you know it's to the left, and if it's negative, you know it's to the right. And I'm not sure if your textbook does it my way or if it does it the other way. I'm trying to remember. So I guess the phase shift is pi over 2 units to the left, and you would say, or negative pi over 2. So I think your book says takes the opposite sign. So let me just go over that so I'm not confusing you. Okay, so here we have your textbook uses this as your model. Wait, sorry, I should have put an A there. So cosine, and then you've got bx minus c. They use a minus sign so that you would take the opposite sign for your phase shift. The phase shift is C over B. So this says negative C, so the phase shift is C over B. And that's what I had there. But in this example, because that's plus, I should put the negative there. So it's, if you're looking at the whole constant, I called this whole thing, and I included the sign. I called that C. I know I said, well, if it's positive, you shift to the left. If this is a positive, you shift to the left. If this is a negative, you shift to the right, just like your transformation function from algebra. But if you're saying, what is the phase shift? Then you would say, like, if you're just talking about a constant, negative pi over 2. And I'm pretty sure on the final exam, they say left or right. Okay, so if you're saying, what is the phase shift? The number would be negative pi over 2. And so this C is the opposite sign there, okay? I know I'm confusing you. Basically, it just stick with the left or right. It's opposite what you think. Positive, this positive means it's left, and this negative means it's right. And I'm pretty sure that's how they say left or right in the, let me just double check. Okay. I know what I'm thinking, but it's hard to communicate it sometimes. So let's see. Try something here. Okay, so see how they say the phase shift is negative 2 pi over 3. Notice that the phase shift is the opposite of this sign. So it's always going to be the opposite. All right. Now, but how would you say that? You would say 2 pi over 3 units to the right. So if you don't look at the sign, if you take the sign away, you would say 2 pi over 3 units to the right, because negative means right and positive means left, but you would ignore the sign and you would say left or right. So left or right replaces the sign, but your answer, this answer for the phase shift is always the opposite of this sign here. That's probably the best way of knowing how to answer that question. Okay. But the multiple choice ones, I think they say left or right. Yeah, if you look at the original equation, your phase shift is always the opposite sign. So you take that C, divide it by B, and then take the opposite sign. Let me do another example so we can clarify this. Okay, so y equals, let's say, -3 sine of pi x minus 2 pi. Okay, so the amplitude is 3. The period is the old period, which is 2 pi, divided by this constant, which is your B constant. Okay, that's your B constant. So in this example, your period is 2. Then your phase shift is the opposite of this sign, but you've got to take this C, this constant divided by, so it's going to be C over B. And in this case, C is, you're going to take the opposite sign, so it's going to be 2 pi over pi. I took the opposite sign, and it just so happens that the period and the phase shift are the same in this example. Okay, but notice that my phase shift is 2. It's going to be the opposite sign of this right here. So, and because it's positive, this is 2 units to the right. So if this is negative, it goes to the right. But if this is positive, it goes to the right. So you just remember, these are always opposite. So just know which one's right and which one's left. And it goes the same, just like you learned in algebra. When you had something like y equals x minus 3 squared, you shift 3 units to the right, because it's the opposite. Right is the positive direction, but this is a negative. So it's always the opposite of what you would think. Sorry. Y equals x minus 3 squared, you shift 3 units to the right. So if you have y equals x plus 2 squared, it's 2 units to the left. The left is the negative direction, so it's always the opposite of what you would think, right? Just remember opposite, and you'll be fine. Okay, I think I've covered that well enough. You should be able to use the unit circle to find, not only evaluate trig functions, but also find inverse functions. And by the way, I want to make a mention. Sometimes you might have a problem like this where it says, well, let me just simple. Sometimes they'll give you, and I'm trying to think, I think it's from this section. Oh, here it is. Well, sometimes they give you a point. Maybe that's from 5.3, I'm thinking. I should have. All right, let's look at this example right here. Here it says the point given below is on the terminal side of angle theta. Find the exact value of each of the 6 trig functions. Okay, one thing you want to, whenever you're asked to evaluate trig functions given a terminal point on an angle. So like in this case, -6, 8. The first question you want to ask yourself is this on the unit circle? And the way you know that is, number one, it may tell you in the problem, this point is on the unit circle. If the point is on the unit circle, then remember r equals 1. And when you evaluate the trig functions, you use the formulas. So tangent of theta equals y over x. Cosine theta equals x. Sine theta equals y. These are very handy formulas, but remember, these are all true on the unit circle. So look in your problem. It may give you a point and they will say this point is on the unit circle. If that is the case, then you just use these formulas. Tangent is y over x, cosine is x, sine is y. But if the point is not on the unit circle, then you have to calculate r. So in that particular example, it was -6, 8. Okay, so in this case, this is not on the unit circle. So here you have to calculate r. R is the square root of -6 squared plus 8 squared, which is the square root of 36 plus 64, the square root of 100, which is 10. So r is 10. So now when you calculate, so for example, if you want to find sine of theta, you have to take your y value, which is 8, but then you have to divide it by 10, okay? That is y over r. So r comes into play. So be careful when you're reading the problems, ask yourself, is this on the unit circle? If it is, r equals 1, you don't have to worry about using r to calculate your answer. But if it's not on the unit circle, don't forget to calculate your r. Okay, that's very important, because then you're going to take your opposite, which is y, divided by your hypotenuse, which is r, not 1. So a lot of times you're going to use the unit circle, but occasionally you might not use the unit circle. You might have to calculate your r. Okay. Now let's use the unit circle to find inverse trig functions. So you're going to need to be able to find inverse trig functions. So you've got to be careful about using your calculator. Your calculator is going to give you a number inside a certain range. So it's really important to use the unit circle. Now, just to review the range, okay. The range of, let's say, sine inverse is minus pi over 2 to pi over 2. And then the range of cosine inverse is from 0 to pi. And the range of tangent inverse is minus pi over 2 to pi over 2. For sine, we can include the negative pi over 2 and the pi over 2, but for tangent, it's undefined at those points, so you don't include it. But these are the range. Remember, the domain of your trig functions is the range of your inverse functions. So your outputs are going to be on the calculator. Your output is going to be here, okay? So just remember that when you're doing a composition, so like if you want to find cosine of, let's see, cosine inverse of cosine, let's say 3 pi over 4. Okay. So you can't just simply, you would think, oh, cosine inverse and cosine, they cancel each other out. So this is 3 pi over 4. Well, be careful. Actually, in this example, 3 pi over 4 is the answer because it's from 0 to pi. But let's suppose this had been sine inverse of sine of 3 pi over 4. Okay, it's not 3 pi over 4 because this is not between negative pi over 2 and pi over 2. So if we look at the unit circle, we see our angle is over here. All right. This is 3 pi over 4. And so when you calculate cos or sine of 3 pi over 4, you get square root of 2 over 2, right? Because your point here is square root of 2 over 2. And then when you calculate sine inverse of square root of 2 over 2, it suddenly puts you over in this range, right? It's over here. And your answer is going to be minus pi over 4 because sine goes from negative pi over 2 to pi over 2. And in the fourth quadrant, the angles are negative. So just be careful when you're doing these problems. Make sure you're taking into account the range, okay, when you're taking cosine inverse cosine. Now, let's suppose you just want to calculate tangent inverse of, let's say, 135 degrees. Actually, sorry, I didn't mean to put that in there. I meant to put 1, tangent inverse of 1. Okay. You're going to go to your unit circle. If you're using your unit circle, and you're going to look at all the different places where tangent has a value of 1. And tangent is y over x. So the only way you can get 1 is in the first or third quadrant, okay? But tangent inverse, so here you're taking negative square root of 2 over 2, negative square root of 2 over 2. This tangent has value is 1, and this tangent value is 1, but the range for tangent is in from negative pi over 2 to pi over 2. So we're not going to take this angle over here. We're going to take the one in the first quadrant, which is 45 degrees. So tangent inverse is 45 degrees. And your calculator, you can use your calculator to do this. You don't have to use the unit circle. Sometimes it'll say use the unit circle, but you don't necessarily have to. As long as you're in the right quadrant. The ones where you have to be careful is when you're doing the composition of two inverse trig function and a regular function. Then you got to be careful. All right. Let's see. I'm kind of going through this quickly. We don't have a lot of time. We still have half an hour though. Okay, also be able to use a calculator to find inverse trig functions. I mentioned that. So they okay, so if you want to find tangent inverse of 3.2, let's do an example of that. So here's your tangent inverse function. And you just type in 3.2 and you can see it's 72.64 degrees. And that makes sense because this is in the first quadrant. It's got to be less than 90 degrees. So that makes sense. If you are doing it in radians, it's going to give you, let's try it in radians. Let's see. Here, 1.267 is in radians. So be careful what mode you're in when you're doing these, when you're using your calculator. You want to make sure your answer matches the right one, you know. So they'll say in the problem, give your answer in degrees or give it in radians. So just be careful of that. Make sure you're able to solve a right triangle and do certain applications of that. That was section 5.8. I don't have any problems where you're having to solve oblique triangles. So just make sure here it says the Statue of Liberty is approximately 305 feet tall. If the angle of elevation of a ship to the top of the statue is 25.6 degrees, how far to the nearest foot is the ship from the statue's base? So this is a good type of example that you might run into on the test. The first thing is to draw a picture. So we've got the Statue of Liberty. And 25.6, let's see, 305 feet. That is the height of the Statue of Liberty. And then our angle is 25.6 degrees. Okay, so always draw yourself a picture. So if this is the Statue of Liberty, it's 305 feet. And then the angle is 25.6 degrees, and we have a right triangle, okay? Now, because it's a right triangle, we can use our trig functions, and you're always going to relate what you don't know to what you know, and you always are going to have two pieces of known information and then one unknown. And so we know the opposite and we know the adjacent. So I'm going to use tangent. So tangent of 25.6 degrees is going to be equal to the height, which is 305 because it's y over x divided by x. So I'm going to cross multiply and I get that x times the tangent of 25.6 degrees equals 305 feet. And then you divide out by your tangent. And you're going to use a calculator. Make sure your calculator is in degrees, as always. Sure. So we've got 305 divided by tangent of 25.6. And I got to redo that because I had it in radians. So 305 divided by tangent of 26 or 25.6. So it's 637 feet, let's say. 637. You kind of want to, ask yourself, does it make sense? I guess that does make sense to me. So, all right, next topic. And it may give you like 3 pieces of information and you have to solve the right triangle. So I think there's at least one problem like that. Let me just show, let's do one example from that. So from section 5.8, solve a right triangle. So this might be something that you would have to do. Of course, it's multiple choice. At least this isn't, but the test is. So you're given, you need 3 pieces of information. The third piece, we're given 2 pieces, but the third piece of information is the fact that it's a right triangle. So we know the angle C is 90 degrees. Okay. So to solve a triangle, you need 3 pieces of information. So in this case, A equals 51.2. C equals 59. And capital C is 90 degrees because it's a right triangle. So when you solve this, so this is the 59, and this angle here is the 51.2. We need to find lowercase a, which is opposite angle A, and then we need to find angle B, and then we need to find angle or side B. Okay. So you're going to first find, let's say, A, and you know the hypotenuse, so you're going to use sine, right? Sine of 51.2 degrees is going to equal your A, which is the opposite, over the hypotenuse, which is 59. Okay, so again, you have this equation that relates 3 pieces of information together. One of them is unknown, and you just solve by cross multiplying. So you get A equals 59 times sine of 51.2. And then you're going to use your calculator. Once you find A, then you can use the Pythagorean theorem to find B. So B equals the square root of 59 squared minus your a squared, okay, by the Pythagorean, etc. Okay, and once you get this one, then all you have to do is find this angle, and you can use the relationship of the trig function. So I think there's one problem like this, but because it's multiple choice, you could probably don't have to do the whole problem, because you'll probably see the answer there at some point. Okay.
For problems like this, could you also use the law of
Not for a right triangle. I mean, I guess it would work, but what would happen is one of your trig functions would go to 0, and that would go out of the equation. So it'd be different. Yeah. I don't have any problems on there where you have to solve an oblique triangle where it doesn't have a right angle. So all the problems involve right triangles. So yeah. So you don't even have to worry about that whole law of sines, law of cosine. Okay. Let's see what else. Also from chapter 6, know those formulas. I'm going to give, I mean, you don't have to know the formulas, but know how to use them. I'm going to give you the formulas. You should be able to, let's go to chapter 6. So, let's see, there, I think, are just a couple from each section. So section 1, these were the kind where you would have an identity to show, verify it. So like, for example, secant x times sine x, you want to show that it's equal to tangent x, or it might say simplify. So something like that. So when you see secant x times sine x, first, one of the tricks to doing these problems is to get everything written in terms of sine and cosine. That often will allow you to cancel things or at least rewrite them in a different way. So this secant is the same as 1 over cosine of x. So I'm just going to replace, use your formulas and see how you can replace secant x with 1 over cosine x. Then I notice, oh, sine x over cosine x, that is tangent. So that's a quotient identity. You look at your formula sheet and you see, oh, sine x over cosine x is tangent x. So you're taking an expression that's a product of 2 trig functions and you're simplifying it down to 1 trig function. That's how you do those. Let's look at another example. Okay, I want to do one that has, let's do this one. Okay, so we have sine squared theta times 1 plus cotangent squared theta. All right, these when you see those squares, think Pythagorean theorem. Okay, so 1 plus, so we have sine squared, and 1 plus cotangent squared is the same as cosecant squared. I think that's right. Let me double check. I always go, so here we have sine squared x or theta plus cosine squared equals 1, right? Now, if I divide each term by sine, this is going to become 1 plus cotangent squared equals cosecant squared. Okay, so I just took the main Pythagorean identity and now you're going to have this formula, right? You're going to have it on your sheet. I just couldn't remember off the top of my head. So here's your formula, and you notice, oh, 1 plus cotangent squared is cosecant squared. So you can replace this with cosecant squared theta, okay? Then you say, well, I want to get everything written in terms of sine and cosine. This is 1 over sine, right? So this becomes sine squared theta times 1 over sine squared theta. Well, now you have sine squared theta, and then it times its reciprocal. Well, that's just 1, okay? So a lot of these, because of the Pythagorean identities, can be reduced down to 1, okay? And I guess we're out of time. Wow, that went fast. I'm going to continue at 2 o'clock. I'm going to continue with the rest of this review, and I will post both links for that, okay? So look for that.